Everyone, I'm Won-Lee. Today's topic is sampling distribution of sample means. I'm not sure whether you understand this terminology or not, but it is just distribution of sample mean, capital X bar. Okay, let's see what it is. All right, we saw, okay, sample capital letters x1, x2, xn. This sample comes from population, of course. Then from here we can get sample mean. It is also what? Random variable, capital letter x1 plus xn divided by number of x's, sample size n. Okay, capital letter. So it is a random variable. These are random variables. So the result, this one is statistic, a statistic, and capital letter, it is random variable, so that it follows some probability distribution function with the mean and variance. If there is a random variable, okay, then that random variable has its mean and its variance. Suppose the population consists of, for example, 15 integers 0, 1, 2 up to 14. 15 population. This is a population. And we obtain a sample size 6 out of 15. Then the number of possible samples gonna be 15 combination 6. I believe you know what combination is. Number of ways choosing 6 out of 15. That is combination 5,005 many. This means we can obtain 5,005 different samples, right? And the sample mean values for each of 5,005 samples are calculated. See, okay, they are population 0, 1, 2 up to 14. Okay, so they are 15 numbers in a population. We choose 6 numbers, 6 of them, then the number of ways will be 5,005. So they are 5,005 sample means for each sample. For example, for the sample 2, 4, 6, 8, 10, 12, sample mean can be calculated as 7. For the sample 1, 3, 4, 7, 8, 13, sample mean will be 6. For the sample, this sample mean 8, etc. How many? 5,005 many sample means possible. This means that 5,005 sample values will be obtained, can be obtained. Some of these 5,005 sample mean values may be the same, right? May be the same, while others may differ. And they will be distributed between smallest value of 2.5, where if the sample values are 0, 1, 2, 3, 4, 5, this means is 2.5, and the largest value 11.5 from the sample 9, 10, 11, 12, 13, 14, 11.5. So smallest sample mean is 2.5, largest one is 11.5. So here 2.5 and 11.5, the sample means will be obtained between here, this range, right? So some of them are equal over there, and the others are differ. You understand that, I think. The distribution of these 5,005 sample mean values is called sampling distribution of sample means. So it is distribution of X bar shortly. And the okay, sorry. It can also be simplified referred to as distribution of X bar, of course, capital X bar. In practice, we obtain only one sample. When we really try to get a sample, only one sample, which is x1, x2, xn, 6 realized values. Okay, I don't know, I cannot specify these values, but from 5,005 possible samples, we just choose one sample. We do not want to know 5,005 many samples. It is ridiculous, right? And from that, we calculate the single sample mean small x bar. Okay, you get it, I think. In other words, here, sample can be chosen like this: 6, 6, like 6, like 6, 6, many. So the size is 6. How many possible? 5,005 possible. Okay? But we just choose one sample, x1, x2, x6, size of 6. From this sample obtained realized values, we calculate sample mean x bar. Okay, that's it. Let's see the mean and the variance of x bar, capital X bar. E x bar is going to be x bar is x1 plus x2 plus xn divided by n, like this. Then operation of expectation, constant will come out here, and e x1, x2, xn plus xn. Then we have expectation x1, expectation x2, expectation xn. What is this? What is this? It is mean, mu, x mean. You don't have to consider this subscript. Okay? What is this? Mu. So there n mu divided by n, so it's going to be mu. Variance, same thing, a little complicated, but x bar minus its mean. X bar's mean, what? Mu, right? And the square, expectation. Then we move mu to upstairs here, like this, and n square, this is a square, so n 1 over n square comes out, and this way. Then you know x1 minus mu square plus xn minus mu square plus cross product terms, 2x1 minus mu, x2 minus mu plus up to 2 xn minus 1 minus mu, xn minus mu, right here. But expectation of this cross product term gonna be what? 0. Why? It means covariance of x1 and x2. x1, x2, dot, 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 x and n are independent each other, because x1, xn is IID, f of x. We saw it last time. So the result is sigma square over n. What is the sigma square? Sigma square is variance of population, variance of x. Okay, I think you understand this simple result. I think it is also important to go further. Okay, I'm not sure it is easy or understandable, but this concept, this distribution of x bar, is, I think, very, very important. It is essential to understand statistics. Okay, this is it today. Thank you. Bye.